Welcome to the tutorial on how to find derivatives on your calculator. What we are going to do here is two problems on how to find the derivative on our calculator. So first, for number one, we'll be finding out this derivative of this long function, which we do not yet know how to do at this point. So there is a derivative button on your calculator. It is located under this F3 button right here where it says zoom. So you have to hit alpha F3. Nope, that's wrong. Maybe it's F2. I don't know. I find it eventually. And then you go down to where it says like n deriv, choice 3, and then hit enter. And then it has this like d over d what? Put x. And now type in your long function. Here we go. So we're going to type in e to the e. Where is e? It's above ln. So it's this really, really long thing right here. Okay? When you have it all typed in, you'll see this bar. This bar just means evaluate at x equals, and x equals what? Pi. So second, pi. You have a question? Question? We're good? When you're ready, hit enter. Boom! Answer. That's the derivative of this curve. Is that it? Yeah, I told you like a 5-minute tutorial. That's it. So f prime at pi equals 1.592. Now in calculus, you can always round appropriately like you've always done, or you can just truncate. In this case, we kind of have to truncate because there's no option. So just kind of be aware of that. Any questions? Okay, you can also graph this function as well. I'm going to go ahead and do that. So I'm going to type in the exact same thing. You can just be a looker-oner if you want to be right now. I'm going to type the exact same thing in. And usually I do it this way. I just wanted to show you how to do it real quick. But I'll usually do everything in y equals. The reason is because I can always pull it up. ln of x squared minus 3. Okay? So I can actually see what this graph looks like. That looks totally crazy. Woo! Okay, so if I hit the trace button, please pay attention. I can go ahead and go and trace everything. First off, why are there no y values right now? Is it because that we have a domain restriction that ln can't be negative? So this is not going to start working until root 3 anyway. So when x is root 3, we're going to start picking up values. So there I go. So if you want to find the derivative on a graph, if you hit this trace button right here, or the second calc, then you can get this dy over dx. What do you think that means? Derivative, and then you just got to type in where. Or you can go ahead and select your graph and hit enter. But I'll just type in pi. And then hit enter, and then you'll get the exact same answer. So two different ways to do the same thing. Your talking is really annoying to me, and I wish you just didn't do it. Okay. Also, you see how I have everything typed into this y1? I usually do that anyways, because all I can do is, now when I do my derivative, x, and then I can go into y1, and then I could just easily do alpha, is it f4? I have no confidence anymore. Yeah, y1. And you get the exact same answer with a lot less typing in. The reason that this is important too, because sometimes on free responses, you're going to get a function that looks like this, and you're going to have to do like 5 different things with it. So if you type it into y1, then you have to keep typing it in over and over and over and over again. So it's much easier. For instance, if I was asking for what's the value of f at 4, all you need to do then is just type in alpha y1 and then parentheses 4, and all that work is already done for me. So in case you want to know what f of 4 is, it's just negative 1.05. And this is calculus. We can just cut that right down to a 4. Or if you want to make that into a 5, be my guest. Doesn't really matter. Okay. Did you know this, by the way? Did you already know this second trick I showed you? Okay, hopefully, because that's a very, very basic one. A lot of these times, when I give you a calculator in your hand, you just got no tricks like this. Things go so much faster. Okay? So go ahead and try 2 on your own. I don't care how you do it. Try 2 on your own. Whoa! I got a huge number. How'd you do? Did you get the same thing? Alright, is this easy squeezy, lemon peasy? Got this down? Hey, something else that you can do too that's totally awesome is, I'll write down a third question. It'll just be graph f prime of x. I'll give you a simple one. Let's do minus 4x minus 4. Okay? This one you could actually do by hand. How would you do this one by hand? You just take the derivative and then graph that. What's the derivative of a parabola? It's a line. Okay? So I'm going to show you how to do this on the calculator. You can actually do all of this. I've been bad at my YouTube videos, my password to my phone, which is the password to my garage door. Very interesting. All you do is go into your y equals. Quiet, please. I don't want to have to tell you to be quiet all the time. It really is annoying. And I'm sure if it's annoying to me, it's annoying to the people around you. Okay, so if I just hit zoom 6, we know what this graph looks like, right? Okay. So if you notice here, my slope is negative, 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 and then it's going to hit 0, and then it's going to be positive, positive, positive. And it's going to be increasing more and more as you get further away. To actually graph the derivative of that, go to your y equals, go down to your y2, and you're going to do kind of the same thing we've done before. So alpha f2 derivative x. And then you can type that in again, but like seriously, I'm the king of laziness. I'm just going to do y1. And I don't have a specific x value. I want to graph every single value, so I'm going to let x equal x. This works very slowly, by the way, because it has to calculate each pixel as it goes. But you can see here, and I'm going to make this line a little different. I'm going to make this a darker line. So the darker line on my graph is my derivative. So when I hit graph, it's going very slowly, because this means it's loading. And there it comes, very slowly, is showing you what the derivative is. So you can actually graph a derivative, which is very important as we move down the road. So I want to get this all out of the way so that when we have problems where it's convenient to use the calculator, I can just show you the quick calculator tricks then for those certain problems. And this should make sense, because look, I'm decreasing, right? I'm decreasing until I get to the vertex right here. So I should have negative values, all right? And my slope is getting closer and closer to 0 as I get closer and closer to the vertex, which is happening right here with the bold line as well. So this should all kind of sort of make sense. I'm hoping that some light bulbs are going off in our heads. Like, whoa. Okay. And that concludes our tutorial on the calculator.